Web as well, because I didn't really know anything about it when I started as well. But what I want you to take away from here is that we're on the cusp of a transition in the way that the web is structured. And it's going to be a transition that affords more meaningful interaction with the web in ways that I'll describe. And I just put this quote up here because it'll become relevant in the rest of the talk. So Thomas Jefferson is talking about transparency in governing. So what is the semantic web, or what they call Web 3.0? So the history of the web, this is a very short, simple history. Web 1.0 was invented by a guy named Tim Berners-Lee, and he did it at CERN, the scientific lab, basically to disseminate documents. So he was approached by his boss, and he said, well, we don't have really an effective or expedient way to share information. So this was a one-way thing. So people could, there was one producer of documents on the web, but a bunch of consumers. So this allowed him to disseminate information immediately and to a broad audience, but that's all it was. It was basically an electronic library, if you will. So the Web 2.0 took that to the next logical step, and it made consumers producers. So it made the web interactive, bi-directional. And that's what we got today. And it's gotten very sophisticated, as everybody knows. I mean, the web is an indispensable resource for all of us today. It's something that we really take for granted. So that's kind of, but the interactivity is sort of limited. If you've ever done a Google search and tried to go beneath the first or second layer of abstraction, you'll know that Google search has some very severe limitations. And it does extraordinarily well with the resources that it has, and it's all about the way that data is structured on the internet. Basically, the internet is today for human consumption. That's its primary purpose, is to present humans data, but when you try and get machines to read that data, it's not as easy like in a Google search. So the Web 3.0 really takes that next logical step and says, well, we want to make a web of data, not necessarily for consumption by humans, although that's an important aspect of the web, but we want to make it for consumption by machines. So we can automate processes that today really cannot be automated, or it's very difficult to be automated. And I'm going to start from basic principles just because I have an engineering mind, and when I started in this journey, I wanted to know. I wanted to know what really from base principles what it is. So that's kind of where I'm starting, and I'm starting in the 18th century. So let's see. What's his name? A mathematician. I have my notes here. Yeah, Leonard Euler. So yeah, Leonard. Yeah, I don't know if you've got the the God equation up there, but anyway, but that's what he's known for. A very smart guy. So he lived in Königsberg, Prussia, in the 18th century, and he was faced with a conundrum. So somebody came to him and said, "Can you go to every neighborhood in Königsberg and cross each of the bridges only once?" And he thought about it for a while, and being a mathematician, he tried desperately to find a closed-form solution for that problem, and he failed. He couldn't do it. It seemed very simple at the time, until he viewed the problem as a graph. So where the nodes are the neighborhoods, and the links between the nodes are the bridges. So that basically spawned this whole mathematical construct of graph theory. So graph theory is a large, very large, but well regarded and used in a lot of domains, section of mathematics, and it's gotten very complicated, of course, and constructs only mathematicians understand. But this was really the nascent sort of the genesis of graph theory. So graph theory becomes important, and again, I'll explain why a little bit later, how graph theory fits into this whole thing. So this next slide is a short video by the man, the Tim Berners-Lee, the guy that I talked about earlier that started the web. And he says it better than I can, really, about what we're talking about.
get back that information. It's not just got somebody's height and weight and when they were born, it's got relationships. Data is relationships. It's interesting, data is relationships. It's got this person was born in Berlin. Berlin is in Germany, and when it has relationships, whenever it expresses a relationship, the other thing that it's related to is given one of those names that starts HTTP. So I can go ahead and look that thing up. So I look up a person. I can look up then the city where they were born. Then I can look up the region it's in, and the town it's in, and the population of it, and so on. So I can browse this stuff. So in fact, I'll just go into one area. If you're looking at Alzheimer's, for example, drug discovery, there is a whole lot of linked data which is just coming out because scientists in that field realize this is a great way of getting out of those silos because they had their genomics data in one database and in one building, and they had their protein data in another. Now they are sticking it onto linked data, and now they can ask a sort of question that you probably wouldn't ask, I wouldn't ask, they would. What proteins are involved in signal transduction and also related to pyramidal neurons? Well, you take that mouthful and you put it into Google. Of course, there's no page on the web which has answered that question because nobody has asked that question before. You get 223,000 hits, no results you can use. You ask the linked data, which they've now put together, 32 hits, each of which is a protein which has those properties that you could look at. The power of being able to ask those questions of a scientist, questions which actually bridge across different disciplines, is really a complete sea change. It's very, very important. Scientists are totally stymied at the moment.
So this is a speech that Tim Berners-Lee gave in 2009. So this has been some time ago. But a couple of takeaways there. So he talks about relationships, the way that, and that's an important aspect of the semantic web, and it allows it to unleash all of this power in search, is the way that datums, that is pieces of data, are related to one another is a fundamental part of the way that the web is structured, the semantic web is structured. The other thing he talks about is silos. So a silo is theoretically, or the way he's talking about it, is when data gets trapped. So, and that happens a lot in the World Wide Web today because, for example, a really good example is our healthcare data. I mean, why on earth today do we have to, every time you go to a new doctor, what do? They give you a clipboard with a form to fill out about your medical history. It's like, I don't remember my medical history, you know. So, but that's the state of the art today. Now, there are complications there. A lot of that has to do with HIPAA laws and so forth, but it's unconscionable in my mind that that data that is resident in a computer in your primary care physician's office is siloed. It's there by itself because their health information system is not generally compatible with the one that the new doctor. So that's what he's talking about, silos, is where data gets trapped. And if it's trapped, it's not nearly as useful as it is as if it's open. So this next slide is Google. So Google has not missed this in any way, shape, or form, and they're putting a lot of resources into it, and he'll describe a couple other aspects of the semantic web that are interesting.
Wouldn't it be amazing if Google could understand that the words that you use when you're doing a search, well, they aren't just words. They refer to real things in the world. That a building is a building, and an animal is an animal, and that they're not just random strings of characters. If we could understand that those words are talking about those real world things, then we could do a better job of getting you just the content that you want off the web.
The way Google is trying to build information about real-world connections is by building a knowledge graph. The knowledge graph is about collecting information about objects in the real world. The object could be a person, could be a book, could be a movie, and many other types of things. For example, for a famous person, we collect relevant data about them, such as their date of birth or how tall they are. We can also connect that person to closely related objects in the knowledge graph.
Let's say you're interested in Renaissance painters, or how about how many women have won the Nobel Prize? By understanding the relationships between things, be it between painters in the Renaissance or women in the Nobel Prize, Google can do a better job of understanding what it is exactly you're searching for.
One of the early phases of moving from being an information engine to becoming a knowledge engine, and these enhancements are one step in that direction.
So they're talking about objects. So that's another name for the semantic web, is an object-oriented database. So you treat atomic structures of data as objects, as real-world objects with relationships. For example, you treat it, if you're trying to store information about a particular dog, you store it as, you conceptually store it as a dog. And I'll go into more. The question is, how do you do it? Now, this is, search, as you know, is Google's bread and butter. You know, and if they can do search more effectively, that will put more butter in their refrigerator, right? So they're not missing this bandwagon. They're on it, and they're spending a lot of resources on it, kind of under the radar. And eventually, this is, you know, this will be embraced by the broader community as well. So how do you do that? So the question is, how do you fundamentally structure the data that's on the web to do these sorts of things? And it's a concept called the Resource Description Framework, or RDF. So RDF consists, whereas data today is generally held in SQL databases, which is tabular, RDF is held in a store called a triple. So the triple consists of the subject, the predicate, and the object. And the subject is the resource itself. In this case, you know, this particular simple example is Joe Smith. So Joe Smith is an object, considered an object on the web. The predicate is the relationship to another noun or adjective that describes the subject. So in this particular case, the predicate is Joe's homepage. So that's a piece of metadata associated with the object that you may want to describe. So the predicate points to the object, which in this case, since the predicate is his homepage, the object is the URL of his homepage. So this is the basic construct of all data that appears on the semantic web. Furthermore, instead of using URLs or universal resource locators, you use URIs, or universal resource identifiers, which includes not only location information, that is where it resides on the web, but also naming information. It's a more rich feature set. So when you get a HTTP address, it has both name and location inside of it. So it's more complex. So this would be an example of a conceptual idea that you, and a way that you might try and store it in a relational database. So the concept is, Harrison has a dog friend named Layla whose favorite activity is chasing a ball. So this is, you know, albeit maybe a richer set of metadata and data that you might encounter in real world, in simple real world activities, but this is how you might store it in a tabular format in a relational database, because relational databases are built on tables. So if you know anything about that, the links between the various aspects of that concept are contained in key cells, or key value stores, like, so 002 in the favorite activity table would point to 002 on the ID table, right? So that's how you make connections between the object and the metadata associated with the object. So there are some problems with that. So this is another sort of, if you did a library in a relational database, this is the way the library might appear. Is you take a book and you split it into its constituent parts that are logical, but maybe not very useful when it comes to gleaning information about that object.
Well, and plus it seems like there's an infinite number of attributes or characteristics for each person, and
that's exactly right.
The ones you care about are different depending on what you're looking at.
That's right. And when you multiply it, this is a very, very simple example, and it gets complicated really, really fast. And this is one of the challenges that people have in discerning data out of, you know, teasing knowledge out of relational databases. So this is that same concept, how it might look in an object-oriented database. So you can see that you treat these atomic pieces of information And each of these blocks is considered, would be a triple in the data store, right? So this I'll just point it here. So this FOF stands for friend of a friend. So that's a standardized, what they call an ontology or a taxonomy for the way that you characterize relationships between human beings and other animals. So so the individuals of these two objects, one's type dog, one's subclass human. That's how they're related. So this is the predicate, right? So they're friends of each other, and so on and so forth. So dog is a mammal, but so is a human, and is a fundamental descriptor, a predicate in the triple store of a mammal. So you have the triple for is a lion and is a goose, and so on and so forth. You know, that's a bad example. This goose is a mammal. And same thing with you know, abstract objects like toys and balls. You know. So the whole database is set up this way in terms of triples. So I talked about, you know, the problems with the relational database, and one of the problems is atomic concepts. So in a relational database, fundamentally, the metadata or the data that's associated with the object is a fundamental component of the table or the data store. So you can see that when you eliminate one of the objects, you eliminate, in some sense, the structure of the data store itself. Whereas in the object-oriented database, if you eliminate the instance of the dog, the concept remains intact with all of its relations. So that's one negative part of trying to do this sort of knowledge activity in a relational data store. So I don't know if anybody's done any programming here, but if you have and you know anything about object-oriented programming languages like C++ and Java, this is a concept that you'll pick up right away. So reuse is a big plus in the case of the object-oriented database, because as you move forward, as you build out these objects in the construct, you can reuse them for other purposes. So the metadata comes, the structure of the database sort of comes for free, and you just populate it with new metadata. So that's a feature of object-oriented paradigms. Metcalfe's law and Reed's law just has to, these are just examples of how the usefulness, it was first applied to telephony, but it's a kind of an attempt at objectifying the value of relationships in data stores. So just to kind of summarize, so if you're looking for a piece of data in the Web 2.0, you of course have to have an href or some sort of reference, a location for the data that you're looking for, and then you just type in that location and you go get it. So in the case of the semantic web, you go after the relationship that you're looking for, and that teases the information out of the triple store. So this is a little bit of a quantitative treatment as to search. This is kind of a mathematical basis, and I don't expect anybody to kind of digest this, but basically you have a factor M difference between retrieving data, complex data, off of a relational database versus an object-oriented database. Now this is extremely oversimplified because people have worked with relational databases for decades and become very clever at speeding up these searches and making, you know, indexes and B trees and so forth. But this is just a sort of a light mathematical treatment of how in some cases, if you have really complex data, your search results are going to speed up dramatically. So this is a little bit of a qualitative treatment. So there are all kinds of different databases. I don't know if anybody's heard of NoSQL databases. So you have SQL and NoSQL. NoSQL refers to a lot of different kinds of things like HBase and Hadoop and those sorts of things where they've changed the structure of the database to be key value stores rather than tabular, so that for certain situations, like if you have very simple data that's doesn't have very many relationships to each other, you can retrieve vast quantities of data very, very quickly. So I'm sure you've seen the advertisements on television for IBM making a smarter planet. That's where they're talking about business analytics, and that's a big deal today. A lot of companies are making an enormous amount of money making sense out of all this data that companies are keeping about supply chain, about manufacturing, about sales, about all that stuff. So IBM is one of the primary companies in the business of making sense of all this data for companies so that they can better do their business. In any case, there's a rich set of different types of databases that are useful for different purposes. So you can see where the graph database is, and Tim Berners-Lee, his vision is to scale that so that it's not only useful for complex data, but also useful for huge stores of data. And the GGG stands for the Great Global Graph. So that what he's envisioning is that all of this data globally is connected all together. And it's a big, hairy, audacious goal, but that's what they're working towards. So the ontology, I talked about that a little bit earlier. It's like a taxonomy, but whereas a taxonomy is more like an org chart where you show the hierarchical relationships between these objects, the ontology goes a step further and describes objects in terms of their metadata and the relationships of those metadata. So this is kind of, so here's another very simple example. You have 4 triples there, and you can see that the concept of an author is shared by 2 seemingly unrelated objects, a human and a novel and a book. But they both share the concept of novel, so try and tease that out of a relational database. So this is the takeaway from this is that the way that the database is structured fundamentally, you're already a long ways down that path of making it a knowledge base rather than just a database.
Now, how does this compare to the expert systems that they tried in the 80s?
Well, expert systems, so that comes into play. So when you're trying to, again, tease knowledge out of these databases, you have to go to some of those concepts or disciplines to make sense of the rules and the relationships that you're teasing out of the data. But the fundamental point that I want to make is that it would be extraordinarily difficult to tease those relationships out of a complex relational database.
True. I mean, that was the whole purpose of expert systems, was to find out what the rules were.
Yeah, and this is a way of accelerating that development, right? So I'll just kind of conceptually what you might envision in the future is being able to interact with computers using natural human language and being able to get relevant results immediately. So that's, but AI and expert systems would be a part of that process.
But like with Siri, I mean, within a set area, you can ask a whole bunch of questions. It'll give you an answer right away, and it pulls from databases all over the place, including Alpha, I believe.
Right. Yeah, it's extraordinary what has been done with the existing infrastructure. But again, you go beyond the first or second level of abstraction, you're lost. Yeah, and that's what we're talking about. So this is a summary slide. Kind of talks a little bit about polysemy and synonymy are 2 problems that is where current Google searches get confused a lot. That is, 2 words that have the same meaning, or two different words that have the same meaning.
That's when you get search results that are completely unrelated, but some word matched somewhere.
Or what's worse is the same word that has 2 meanings or more.
Yeah.
Right.
But Google gets around it because it looks at what people normally search for, And so, you know,
Right.
it's really good at guessing what you
It
need.
is very good. I mean, based upon, you know, what it has to work with, it's done extraordinarily well. But I don't know about you guys, but I encounter limitations of Google search all the time. And what you end up having to have to do is changing your keywords, because that's what Google, you know, that's the only way it gets to where you're trying to go is through
And
keywords,
you know, when it
right?
gives you, you know, it kind of brags in the upper right corner, you know, 4 million results in
Yeah.
Right.
2 seconds.
That is just
It's like,
useless.
you know, you're not gonna
Right.
look at more than a couple dozen.
Yeah.
Hits.
Probably won't get off the front page.
My
Yeah.
biggest frustration lately with Google and searching is that you end up with all these advertising sites. It doesn't take you where you wanna go or to the information you need. What a list of,
Yeah, they have the click farms and stuff like that, and you go right.
exactly.
And it's just junk what's written
It's
on
junk.
the page. You
It's
just
just
waste your
so
time.
frustrating.
But
Well,
then they got your clicks. So
And that's the other thing. So you know about SEO, right? Search
Mhm.
engine optimization.
she
So-
does it.
Yeah,
Yeah.
that's the fraud thing. where
So
they
what
bump
is
people
search
up
engine
in the rankings.
optimization? It's gaming the Google system
Yeah.
Exactly. And
to
it
get
keeps
your
changing.
results to the top, and that's not necessarily what you're looking for, right?
No.
So that's one of the good things about the semantic web is that it's very difficult to game this system. Very difficult, if not impossible.
Yeah, because it's not just
That's
words,
awesome.
it's the idea.
Yes, I'd take that in a minute.
So this next slide is another short video from Ian Robinson, who is the CEO of a company called Neo4j. This is Neo4j is one of the main practitioners in the semantic database world. So he's got another. Oh shoot. So one thing I wanted to describe here is so where does the semantic web and this sort of construct really make sense? Well, data that has a lot of relationships is very dynamic, that is changing all the time, and you have a need to extract meaning out of that data. So that's the sweet spot for the semantic web construct, Web 3.0.
Now,
So
most
this is Ian
organizations
Robinson.
today do employ relational databases, and what would you say is the typical inflection point at which these organizations realize that I need another solution for my persistence?
Probably the biggest reason very often is simply performance. If they have a relational solution and many of those queries are beginning to deteriorate, then it may be a result of they've got many join tables, or certainly lots of queries that depends upon joins and recursive joins. And those kind of queries will deteriorate as the data set size grows. So that's one of the forces that kind of pushes people into looking for an alternative solution. It may be that their data or their domain is just very messy, and actually they're finding it very difficult to lever it into that tabular model that the relational database gives you. So again, if there's a high degree of semi-structure or a high degree of variation in the domain, then that's another thing that tends to encourage people to look for an alternative data model. And for both of those things, the graph is ideal. Large volumes of highly variable, semi-structured, and densely connected data. That's the kind of stuff that we're very, very good at capturing, storing, and querying.
So, kind of reiterating in better words as to what we're talking about, just performance. You heard performance, and I gave this talk about a month and a half ago at the Big Data Meetup at the Innovation Pavilion, and that's something that those guys gripe about all the time, is dealing with these large data stores as performance. When you try and really try and start instructing it with complex rules, trying to tease knowledge out of those data sets, it starts bogging down heavily. So this is a case study of highly connected, very complex data. This is a graph that shows the various aspects of the Dodd-Frank Wall Street Reform Act.
Cool.
So you can see that it's a complicated
That'll
mess.
simplify things.
And the financial services industry is grappling with this mightily. They're spending hundreds of millions of dollars trying to solve this problem. Here's another view of the same thing. So this is a good example of a domain where we've been on conference calls with IT leads at Standard & Poor's and Goldman Sachs and so forth, and they're very interested in this technology to help them make sense of all of this stuff.
So wait, you're going to enable more horrible bills from the politicians?
Yeah. Well, I mean, you know, this is what it is. I mean, I don't want to get into a political row about whether this is needed or not. That's not my place. But in any case, it is what it is, and the financial services industry is going to have to deal with it. So, and the now that they've invested, you know, zillions of years and, you know, tens of millions of dollars into their existing infrastructure, it's a shift that really is hard to turn. So if they had started with an object-oriented database, they'd be much better off today in terms of adapting to these new rules. But so they're looking for alternatives to the state of the art. So this is a very basic architecture. So 90% of the web, the data on the web, is unstructured, meaning it's not structured in any particular way. So that's one big challenge of doing a semantic build-out, is doing what they call the extract, transform, and load piece, or ETL. That's what I call the structurer. So that's a big piece of software that has to be written. And once you do that, then of course you can get it into the triple store. Inference is the process by which you infer relationships between objects that are not explicitly related to each other. So that's the inference and rendering engine allows you to visualize now this data, and that's useful to businesses.
So that goes through when you have 2 or 3 levels of separation, like dog to novel, because the dog is owned by the person who wrote the novel or something.
So again, the data that's on the web is unstructured, right? It's typically in documents or in SQL databases that maybe are unstructured or maybe semi-structured. You know, companies and individuals are throwing data on the web sort of haphazardly, not with any sort of ontology or any sort of hierarchy or organization in mind. So you got to kind of make sense of all of that. And how you do that is very dependent on the particular domain of the data that you're trying to. So you do that differently for healthcare data as you would for financial data, and so forth. But that's a big challenge for this transition.
So you're searching in the triple store instead of like just index
Correct.
documents.
That's correct.
So
yeah, and that's where you get some of these efficiencies. Is once you start with a concept, now the traversal of trying to find a related concept is just a matter of traversing these relationships, right?
Yeah, but you got to set up all those relationships.
Oh, of course. Yeah,
Takes
that's
forever.
that's the you're now getting the sense of what the job at hand, how challenging it is.
Yeah.
who's going to own it and
Right.
control it?
But you have to. But it has to come with automation. I'll talk about the drivers for this in another slide. But there's some powerful drivers for this transition. This is the web stack. I don't expect any. This is not very meaningful to me even. But this is the OSI, an attempt at an OSI model about how the semantic web is built out. That's more useful for people who are software professionals. So this linked open data cloud, this is a website that kind of tried to keep track of all the websites that are sort of linked together in this kind of fundamental way. This is what it looked like in 2007. And so it's not a new idea. The Scientific American article was written by Tim Berners-Lee back in, I think, 1999. And that PC Mag article, What the Hell is an Object-Oriented Database System, that was written in 1995. So this is not a new idea. So that's what it looked like in 2007. This is what it looked like in 2009. So it's growing exponentially.
And this is what is growing exponentially? Stuff that's
This is
been processed and linked?
Yeah, so this linked open data cloud is talks about RDF stores that are actually linked to each other in the way that I've been describing. So
all of the information that people are inputting is residing in the cloud, is
Right.
there and connected in some way.
correct.
But we're also going to be dealing with a lot of privacy issues.
That's true. That's true. I haven't really given it a lot of thought, but I don't know that this paradigm shift really makes that problem any more, onerous than it is today. you know,
Just
we have
makes it
privacy
easier to
issues
search,
today.
but yeah.
Right. I mean, the fact that people can hack computers and get at private data, that's not going to change.
No.
That's not going to change. Here's a list of some of the practitioners and vendors and those that are sort of embracing this concept. I'll just go through a couple of them. GoPubMed and NextBio, these are practitioners, and these are really putting really good use to this technology in biotechnology, you know, exposing research results and so forth to better collaborate. GoPubMed is actually doing that for periodicals. So it was a real problem for biological researchers to get at the prior art, if you will, information about the particulars that they are working on. You know, and they're talking about really complex concepts like, you know, cell membrane and whatever. But anyway, so GoPubMed was created by a company called Transmeta or something like that. That's not important, but anyway.
But for
so
researchers,
that's been a very important resource for bio researchers. Topsy, that's an interesting example. They have over $500 billion. Topsy's job is to capture every tweet that's ever made. So they've got over 500 billion tweets in their database. And you can go search it. So that's important for people who want to do research on social issues and so forth. Consortia, there's a World Wide Web consortium. This one is led by Tim Berners-Lee himself, trying to drive this concept forward. The Sunlight Foundation is a lobbying group that's lobbying for these transition to these sorts of technologies that will help make government spending data transparent. Eurovox, same thing for Europe. Europeana was a EU funded. They put $500 billion into this project to make antiquities and arts data available to everybody in the European Union. So they're embracing this concept. DBpedia is Wikipedia in a knowledge graph. It's a community-run. Same with Freebase. Freebase draws its data from other resources besides just Wikipedia, but that's one of the main ones. And these are ontologies. So that's, as you mentioned, that's an important part of building out this structure, is making sure you get the structure right? Because if you're linking to providing, you know, not accurate relationships between objects, that's bad. So SIOC is an ontology for social media data. Good Relations is for e-commerce. GEO is for the gene ontology for the Genome Project. This is the symbol for FOF, friend of a friend. And FIBO, so this is the Financial Industry Business Ontology, and this is a project that started about 2 years ago to build out just what it says, a financial industry business ontology, to to organize all of these hundreds of thousands of various transactions in the financial industry. And the end result in that is going to be perfect transparency for the regulators so that they can follow. As a matter of fact, the one aspect of FIBO called the LEI, or the Legal Entity Identifier, is now mandated. And so if you want to be a financial industries, do financial transactions in the United States come, I think it's July of 2015 or something like that, you have to tag every transaction with this global identifier so that the regulators can always trace that transaction back to its source. So this is a global initiative, and the financial industry is being required to adopt this. Again, it's a big problem for them, but that's just one aspect of FIBO. Conferences, the Semantic Web Technology Conference, and so forth. This is FacetApp, is the company that I'm working for, and I'll talk a little bit about that later. I'll post these slides so you can read the testimonials. So these are some of the drivers for the paradigm shift. So as I described, hobbled analytics, so not having access to structured data to allow you to look at this data in a meaningful way in terms of automation. So that's driving a lot of the adoption of the technology. Poor collaboration, like in the medical and the biotech industry. Opacity. So that was, why didn't we see this financial crash coming? Well, large reason is because we didn't see it coming because we didn't see it coming. I mean, the regulators just had no, yeah, and it, you know, fair enough. It could have been intentional in some certain aspects, but the bottom line is that,
was intentional.
yeah,
Yeah, I
the bottom,
agree with that.
yeah, the bottom line,
Picture of that haystack.
Yeah.
yeah, the bottom line is a lot of this data is just inaccessible. You know, it's siloed, as we described. Total cost of ownership, and you know, just performance, as the guy from Neo4j described. And another thing that's coming online, you know, we can talk about toasters connected to the internet, which doesn't make any sense. But the Internet of Things is going to drive a lot more data to the web, right? And we're going to want to make sense of this data, and we just can't do that effectively with current technologies.
I know all these computers are nice and all that technology's nice, but you know, there's so much stuff can happen through all your data and everything else, and you use it for the wrong thing.
That's true.
And we're actually creating a, you know, communism atmosphere.
Yeah, it's like for every good
in
thing you
computers.
create there's another side to it.
Yeah.
It's not
Yeah,
so
that's
good.
true.
No, exactly. It's called the dark side. And it exists all over in computers. But you know, is there a way to, you know, control computers, and any company would use that data for false, for their own personal aspects, to actually get fined and, you know, and be arrested, you know, if the FBI come in here and the, you know, Department of Justice come in here and take control of these things.
Well, sure, and I think a part of that challenge is just what we described about, about the financial crash, and just the opacity of the data, right? So that's one thing that there's a lot of lobbying going on today to try and open up that data to the public eye, and this is one way to do that.
Yeah.
So just imagine. So I started into this project because I had a pain point as a project manager and electrical engineer. So one of my primary pain points in doing that job was keeping track and viewing bills of materials for electronic boards, right? So you produce a computer board, and it may have, you know, several thousand components on it. And if you work in the medical industry, that data is sacrosanct, because if you're not putting the right parts on that board, you can kill somebody, right? So it's really important, and those part numbers they can be this long, right? 29 digits or whatever. You transpose one, you can kill somebody. Transpose one digit, you can kill somebody. So the way that we were, the state of the art, and that's slowly changing now. There are some other alternatives out there now, but in general, the state of the art is the single source of truth, that is the engineer that has designed and tested and validated this piece of hardware, puts his bill of materials into a spreadsheet, into an Excel spreadsheet. That data has to be consumed by a number of people, and so that data gets out of the single source of truth, out of his control. And furthermore, it's got to be viewed in various ways, by purchasing, by supply chain, by, you know, manufacturing, by any number of other people, and sometimes the data has to go outside the company. So that's a real problem, because we were finding lost parts and wrong parts, and you generate a lot of scrap that way. So this is another example of a place that's really ripe for this sort of technology to be adapted, because it can be bolted on to an existing infrastructure. And I've been working on doing electronic ontology. We actually did that in my last job, because we tried to solve this problem. So that's what kind of got me started in this. I saw a real opportunity there. Some of the barriers, financial, as we talked about, it's a big ship that's going along. It's going to be hard to turn. Practical, you know, there's just not a lot of talent out there. There's not a lot of people that know about this and are skilled in the art of doing this. It's building up. One of the job descriptions that's coming online now is somebody called a data scientist, who is sort of charged with writing the ontology, basically, making sense of of all of this data, and making the business case. That's been a real problem, because you can't really describe the benefits of this in an elevator speech. It's really hard to do, and unless you're kind of have a pain point, or trained in software development and so forth, and know about databases and so forth, it's really hard to get the message across.
Well, and what is your selling point? That they can find info they couldn't find beforehand?
Basically, yeah.
Okay.
Time savings, probably.
Right. And you could kind of argue that until the web has kind of embraced this concept, until it's entirely built out, you kind of don't get all of the benefit of the semantic web. But again, as I'll show in the next slide, there are domains and particular data sets where it's just becoming a necessity. So that's one of the drivers here, is just necessity. Some domains and some particular data sets, they're finding that we just can't do it with traditional technologies. We just can't do what we're trying to do. So
That's because you need liquid microchips.
yeah,
Really?
yeah.
That's cool.
Tools are coming online. So FacetApp, that's a company over. Franz is another one. They're starting, enterprise level tools are starting to come online. Accelerators and incubators, just consortiums, industry-wide consortiums that are kind of banding together to make this happen. Awareness, that's kind of what I'm doing here, is I'm trying to build awareness. And money. I don't know if you all saw that article in Time called Bitter Pill about the state of the healthcare industry. Very interesting article.
Recent?
It's 3 months ago now, or something like that.
Have to Google it.
Yeah, it's a really good article. I encourage everybody to read it. But we got a real big problem with the cost of healthcare in this country.
Yeah, it's
And
like the cost of computers goes down, and we get more for our money all the time, and in healthcare you get less for your money all the
And it
time.
keeps going up.
So money is a real big driver. I mean, if you can afford efficiencies like we were talking about, if you could make this data shareable and readily accessible by service providers and so forth, that would go a big way to reducing administrative costs in running our healthcare system. So,
Do you think these new databases, I mean, are people going to put together like segments of relation databases and then charge an access fee for that level of search? Or?
possibly. It's kind of hard to say how this is all going to play out. It's kind of the Wild West right now, but we'll see.
And maybe companies just build ones to make their company work better, because that's where they justify the money, and
Well-
then eventually they'll kind of link.
Well,
between
that's what
them.
we've been thinking. We've been kind of pursuing business opportunities where you have a nascent business, an emerging business, and they have need for capturing a lot of really diverse, highly dynamic data and making sense out of it all. So we're kind of pursuing business opportunities like that where they're just starting from scratch. They haven't invested all of this time and energy into a traditional relational database, and those folks have been more amenable to looking at this. But the problem with that is that these emerging companies are not financially stable, typically, and one out of 10 makes it, right, and that's about what we've been encountering. And our strategy has been to kind of build out proof of concepts, or POCs, for these guys, and to show them how it works. And heretofore we haven't, we've gotten some money out of these guys, but heretofore the business, for whatever reason, has failed in one way or another. So we had an interesting project, Heaven, the Hawaii Electrical Vehicle Network. So it was a group of guys that wanted to do basically a car rental agency that rented exclusively electric vehicles. And anyway, so that we got a retainer and all that stuff, but they kind of dropped off the radar anyway. So here's just kind of the business perspective. This is a graph of 2012 in NoSQL databases, which object-oriented databases are really kind of not really accurately considered NoSQL. They're something completely different than Hadoop and other sorts of SQL databases that are different, but it's considered so Neo Technologies is down here with 9 U.S. millions, so 9 million in business. So that's that's getting there. Here's just a sort of a laundry list of community and regulatory statutes that are coming online with regard to data transparency, and these are drivers. So this was an executive order that was signed this year, a couple months ago, instructing the OMB, the Office of Management and Budget, to put hooks in place, put procedures and technology in place that makes government spending data transparent. So this was an edict that was laid down by President Obama. He said, you will do this, and it went out to all the agencies. So this is the sort of thing that's sort of driving the adoption of these sorts of technologies. Pew study conducted in 2010. Basically, this is kind of confusing the way they worded this, but in essence, it's saying in expert responses, 371 experts, that's subject matter experts in database and IT. The gray box says, you agree that by 2020, the semantic web will make a significant difference in the way we use the web. And over half of them said yes. So the experts agree that this is something that's coming. So this is Tim Berners-Lee, his World Wide Web Consortium attempt at kind of providing incentivizing people to do linked open data. So he's created this sort of what do they call it, seal of approval.
What does RDF stand for?
RDF is the Resource Description Framework. So linked RDF is the triple store that we were talking about. Yeah. So having a good keeping house seal of approval for linked open data. So these are different levels, 1 star to 5 star of linked RDF, and hopefully kind of enticing the industry. It's like a CE mark or something like that. So that's kind of the way they're approaching incentivizing companies to do it. Unintended consequences of the good kind. So what I just listed here are a lot of domains where this technology would really prosper. Arts and humanities, as we saw in the Europeana. Real estate, you can find a lot of different examples of where this might be useful. E-commerce, education, a lot of domains where this would be a nice paradigm shift. If we have time, this linked open data was a speech that Tim Berners-Lee gave a year after his 2009 speech that I showed you earlier, that showed kind of demonstrated how it's being adopted by the industry. So get the word out. That's kind of what I'm doing. Build proof of concepts. Facilitate ontology development, which is an important aspect because it's a standard. So it takes a while to build those standards out properly and with industry input. Nurture community and industry involvement in these ontologies and so forth. And just innovate, start finding a way forward using our innovative. So here's some further reading. I'll post these slides so you can look at, you can do your own research if you'd like. And some terminology there, you can look at that in there. So I'll just, the Facet App platform. So Facet App is a company that was started about 8 years ago now. And because I won't go into the details, but he had a pain point that he couldn't solve with relational databases. So he saw the promise of the semantic web as a way to solve his business problem. So he embarked on a journey of building out something that he knew could solve his problem. And they've been working on it for 7 years and have built a platform called Facet App that's an API that allows people to build out completely model-based semantic apps without programming. So nobody in the world has done this. And when I say completely model-based, that is what you produce is in every aspect model-based. In other words, it's not only the concepts that are contained within the database and the metadata that are model-based as we've described in RDF, but the widgets. So everything you see on the screen is an object. So the tables are an object that you see on the screen. The other widgets, the drop-down boxes, the radio buses, the radio buttons, the faceted search on the side. It's all model-based, completely model-based, and nobody's done this before. It's always been some sort of mashup of traditional technologies, HTML, and then semantic. So this is we really believe this is the natural antithesis of building out this technology. And they've done it in such a way that you can build these applications without knowing PHP or JavaScript or anything like that. It's a matter of plugging
So you're building web-based apps,
web-based apps. Yeah.
and they'll use that data.
Mm-hmm.
And so you have this one cloud of data for everything in the company. And then you build various
Potentially,
apps off of it.
yeah, and you can also bolt it on using other technologies like Ajax and so forth, bolt it onto an existing infrastructure. So if you have a particular data set like I was talking about earlier, the bill of materials for electronic components,
Right.
you could keep, the basic infrastructure as it exists in your company, and just use the Facet App technology for that data set, because that's where it works. And you don't have to upend your whole system. So that's what I've been working on. And like I say, we've had some success, but again, the problem is explaining this to be all the things I talked about before.
So Neo Technologies, that's your no, your company is a
No, Neo4j is our competitor,
oh, okay.
and
Facet
Facet App is the is our company.
That's your company.
Yeah. Well, it's not mine.
And
I'm just right now I'm just a consultant and an investor. So my company is called Gadgetronics, but
Gadgetronics.
Partnering with Facet App.
Fascinating concept.
So it's got a lot of promise, but we haven't found a way to really monetize it in any sustainable way as yet.
But
So
there might be some amazing links found, and especially in the world of medicine, you look at these disparate research projects and you see
Yeah.
where they're connected. And
we attended the Semantic conference in San Francisco in June, I think, and we contributed to the FIDO Summit. Put in our 2 cents. They had a bunch of round tables about how the best way to do this and so forth. There's a lot of controversies in the community, but it's a pretty tight community. It's a very small community, but it is growing, and a lot of research going on, especially in what you talk about, AI and making really business intelligence, making sense of all of this data in ways that just cannot be done with a traditional relational database. So, any questions?
I mean, the way I see it in general, it's very positive in things, because your online searches will just be much better quality for products.
not to mention, you can come up with ideas and stuff, because you'll see stuff linked together that you
Right.
didn't
Yeah.
think about. It's
You
going to be a
know,
while before
Yeah,
it's
it's going to be
out.
a while, but I'll go back to the example of electronic components just because that's what I know. But again, the state of the art is just well, I'll just I'll date myself a little bit. But what we used to do is when we were looking for a component, we would go to a library. It was an on-site library. It was a room about this big, and it was filled to the brim with data books. I mean, I kid you not, thousands of data books. And you'd have to search page by page through these numerous data books, try and figure out which is the proper one to get at, and look at, try and find the component that you're looking for. So we're just one step beyond that, because to find a component today, you have the access to the internet. Of course, all this data is on the internet, but it's all over the place. If you want to find a particular capacitor to do a particular thing, you got to look at TI, you got to look at National
It's
Instruments, you
kind
got
of
to look at
haphazard.
Yeah.
Oh, yeah.
And
Because every vendor has their own.
Every vendor has their own standard.
yeah.
Every vendor, the data is presented differently, it's stored differently, you search for it differently. It's a mess.
So if it's by the meaning instead of the way it's stored, then you don't care how it's stored. You care the
Exactly,
connections.
exactly. So I envision a world in which there's an ontology, there's an electronic components ontology that everybody's embraced, and said, we want to provide the best value for our customers, so we're going to store our data, we're going to organize our data in the standard way, right? And so you do one search, and it searches for the optimal thing, and you get results from every vendor immediately. And that's the world that I'm envisioning for this.
From a marketing perspective,
Yeah.
you're an all-out war.
Well, of course, but look at it from the standpoint of capitalism. It's what Miku Kashu, the guy who he's a physicist that wrote this book, The Physics of Everything or whatever. But what he calls perfect capitalism. It's perfect capitalism because everybody's playing on a level playing field. There's no SEO. There's no can you find us, or gaming the system, or saying, you know, mine is better because of this trumped up
Right, you're removing
aspect.
friction.
So no
You're removing
advertising.
friction.
Full-
Exactly.
Full disclosure.
Full disclosure, and everybody has to compete on the basis of merit rather than who has the biggest advertising budget. And that's perfect capitalism.
Sounds like an engineer's dream.
But then I don't
No.
But
Besides, people don't go just on
Doesn't work that
specs.
way.
well, another aspect of that, or a problem I can see that will come up, are things like research, where it's funded by a private entity,
Oh, right.
and the results of that
No.
research are skewed. And so they'll just keep funding more research that gets them the data they want. It all goes into this big pool, and we're all buffaloed.
Right.
Well, you're absolutely right, and we encountered this with financial data. So Standard & Poor's, they make an enormous amount of money selling this data. They don't want it transparent. They don't want it. They want that silo because they make a lot of money selling it. But the counterpoint there is, but now they're being required to be transparent. Now
Yeah, but then they're not going to spend the money acquiring the data. It takes a lot of money to go do all that research in the first place.
well, but okay, but if everybody gets on the bandwagon, that data has to be stored somewhere. They have to, that transactional data, to run their business, they
Right.
have to have that transactional data somehow. So why not put it in an open data store that's available to the regulatory agencies?
So maybe it's one more middleman that goes away, because this whole
Exactly.
internet stuff. So maybe
Exactly.
they go away entirely
Well,
because
Standard
you can just access the data.
Standard
anywhere.
& Poor's is a financial services company, so they make money doing other things as well.
Okay, so let's still do that.
That's not but it is a big chunk of their business. So they're going to have to find other ways to make money.
Well, it's like real estate agents or travel agents. I mean, they've pretty much gone away because the web gives you direct access to the
Right.
information. You don't have that gatekeeper.
Right,
So
but still,
if everything becomes transparent like that, a lot of middle people.
well, and
go
travel
away.
information is another domain where maybe this could really have some benefit. Again, perfect capitalism. If you today to find travel deals, you got to search numerous sites, and
Right.
some of this is aggregated already, like Travelocity, right? That's their big claim to fame, is that you do one search and they look at all of these different data sites but there's they have relationships with those guys, and that's imperfect.
Right. Some pay for better results. Those
Exactly.
things, and it's back to SEO. And
Right. Exactly. So
Yeah, they do. I mean, this data storage is the way of the future. No matter how we get to it, there's more information, more control.
well, when you
can't
consider
stop it.
that 90% of the data that's on the web today has really been generated in the last 48 months. I mean, that tells you this is not going to slow down. It's just accelerating. So it's with us. All of this broad use of data is part of our lives now, and it's really, in my view, there's no going back. I mean, it's just indispensable from my perspective. I mean, I look at the web has just transformed our lives really in so many different
It's
ways.
hard to think about, like, the way
Exactly.
Yeah.
Yeah. But there's the profitability aspect is suppressing a lot of data. Because people are
because
looking
people
at.
want the silo. 'Cause
Yeah.
that's the
That's
gauge.
right, they want to protect
That's
their
the gauge they
information.
can charge you to go through.
Yeah, just like the GMO issue. Kellogg's does not want you to know what they're putting in there,
But you want to know, right?
but I want to know.
Sure.
But they're
And-
suppressing it.
Well, sure,
But
they all
you,
do that.
and now the question is,
But maybe you only buy from cereal companies that tell you what they put in.
but
And
but
so
now the question
competition
is,
drives it.
should you as a consumer, is that a reasonable expectation that you gain access to that data? And I think, yeah,
I think so too.
seems like a reasonable expectation.
Even
But-
personal health,
But if they go
healthcare.
in and buy the elections, like they did in Washington, California,
But you don't have to force them. You could just be competitive pressure. Except now there is a law that says you're not allowed to label whether or not you're using growth hormones and stuff like that. So that's
but that,
bad.
see, that's the other
Right.
side of it, that's what they've
They're
pushed.
using the
Right,
government
so
to
then
cover
you
it
get
up.
things like, what is the pink slime in the beef? And
Right.
then if somebody didn't
Right.
expose
That's a good
that, they'd get
example,
away
yeah.
with it, because
Yeah.
it's a profit.
Yeah.
Yeah, it's
If they
just
don't have
protein.
to disclose it,
And the bigger the corporations, the worse they get.
Yeah.
And it's just,
Seems that way.
they're the ones who really want all this data.
Right.
This is for
But,
self-control.
but I must say that in our, I'll restate that in our discussions with some of these financial institutions, the tech guys, that is the IT guys, they get it. They really get it, and they really want to go this way. But the industry, they're the guys with the purse strings are telling them, giving them other information. So, it's going
Well,
to take
you got to
time.
show immediate profitability of doing this, because that's a
Exactly.
huge
Exactly.
investment.
Well, here I'll just
taking money out of
on-
somebody's pocket that has a silo.
On that note, this is a testimonial by Standard & Poor's, Gene Mashenko, who is a lead information architect at their rating services, and this is a testimonial from him that using our platform to do what they did traditionally would have cost an extra 2,000 hours. They would have saved 30 to 70% of their budget would have been saved if they had adopted this technology. So.
Well, that'll help you sell that.
Yeah, I mean,
Yeah, as
so
opposed to
we have the
traditional, right?
testimonials, yeah. But again, it's a big ship that we're trying to turn. Standard & Poor's, I mean, can you imagine how much money they've invested in their current infrastructure?
Oh yeah.
I mean, it's mind-boggling.
Well, and all companies have huge investments in their data.
Well, they do,
Processing it.
they do, but again, smaller companies, of course, have invested less, and that's why we've been focusing on emerging, startups.
Most of the computer systems throughout the world, and the big corporations are all IBM systems, aren't they?
No.
Pretty much. The-
Well, that's a complicated
That's
question.
That's all FBI has,
Yeah.
and that's
It
all
could-
they use.
It could be.
I know they do.
Well,
So-
IBM is it's a huge company. They do hardware, software, services, all that stuff. So they're in a lot of, but Linux. There's a lot of open source penetration into that industry. A lot of Red Hat, Linux, and Hadoop is an open source project, and that's for big data. That's being used quite extensively. Although as with all open source, if you know anything about that, there's a very, very steep learning curve. So that's kind of what you either buy a licensed product. That's the way Red Hat has made its name.
Oh yeah,
right?
with Linux, yeah.
You buy a licensed product and get support, or you don't, and you don't have to pay the license fee, but you got to support it yourself. So that's the trade-off.
So I used to write database programs for
did you?
small companies, some medium-sized ones,
Cool.
and for little departments of Dow Chemical and stuff.
Cool.
So would somebody who's freelancing, would they want to use that as a way to develop a database, or for small companies, there's no benefit
Well,
doing that kind of stuff?
Well, it depends. It depends on your data set, how big it is, how complex it is,
Right,
and
so-
whether or not you want to extract meaning out of it. You gotta have those three aspects. Those
Yeah.
three concerns.
So you got to be a relatively big.
Yeah, yeah. You gotta have. There's a tipping point there, and the other aspect of this is they've built this technology on the world's fastest inference engine called Ontobroker. It's a German product, and it's not cheap. The inference engine, it's state of the art. It's the best in the industry, but a seat of Ontobroker costs about $100,000.
So
So
is,
they-
when you say inference engine, is that a hardware or software thing, or?
And that's not hardware. You can run it on any piece of hardware that's capable of running that, but it's software. It's database software. It's a triple store, and the rules engine that goes along with it.
Right. So you can find all those links.
Yeah.
Thank you very, very much. I
No
know
problem. I hope-
Probably 60% of that